Now in this video, I'm going to give you an assignment. So with what we've covered so far, you should be able to do these tasks, but they will be tricky at this point. So again, if you can't get it to work correctly, don't worry about that. It's a learning process. I want to get you thinking where you have to problem solve and come up with these solutions yourself instead of just following what I do. So if you don't get them correct each time, that's fine. But each time we do this, you're going to get closer and closer to learning how that problem solving thought process works. And then you're going to learn to do this on your own. So now the assignment's going to be to make our moving platform move up and down. So you are going to have to change the if statement that we made a bit. The logic in there is going to need to change. But the underlying concept, we're going to want some type of variable that saves whether the platform's moving up or down. Then we're also going to want to save the end position this time, not just the start position. So we can still use our distance to stop and control how far the platforms are going to move. But before we start moving, we want to save that position of where the end is. So you can do that very similar to the start position we did, but you're going to have to add something to it. And then what we're going to want to do is use our transform.translate to move up as well as down, depending on that variable, if we're set to move up or down. Now in there, we're also going to need to check, because when you're translating, you're not moving an exact amount every frame. It's going to depend on how long the frame took. So you might go past the endpoint. So you don't want to just do a check if we reach the endpoint. If we use the exact position of the endpoint, if we overshoot it a little bit, we're never going to equal that endpoint. So we want to make kind of a little buffer zone. So you're going to need to use, in your if statement, when we're checking the distance, you're going to need to check if we're within a certain distance. So usually I would use 0.1 as your value. So basically, if we get within 0.1 distance of the start or the end position, we're going to consider that we reached it. Okay, so that should be everything you need to go on there. It may take a bit of practice. Play around, give it a shot. Even if you want to do some Googling and try to research a bit on your own. Remember, game dev isn't an exam. There's no cheating. You need to get to a solution. Learning how to find those resources is a great way to practice. So if you want to do some Googling, if you want to find a YouTube video, whatever helps guide you, that's completely fine. Don't feel like you're cheating yourself. Game developers always look online for resources and documentation. That is completely normal. So give this a shot and I'll see you in the next video and I'll show you how I do it. All right, I hope you were able to get some progress on that. If not, just follow along and I'll show you one of the ways that comes to mind of how we can do this. So let's open our moving platform script. And to break it down a bit right now, we're checking the distance from the start position to our platform. And if it's not in the distance to stop, we move it up. So I'm going to need to restructure this a bit. So the first thing I'm going to do here is I'm going to make a Boolean variable called isMovingUp. I'm going to set it to true. So by default, we're moving the platform upwards. Now I'm going to comment out this code just for the meantime. So I have shown you quite a few times where you can do a double slash to comment out a line. But the other one for commenting multiple lines is doing a /, then an asterisk, and then at the end we do an asterisk and then a /. So what this will do is comment out anything that's between these two little codes that we put in. So you can see this bracket is fine because it's not green, and so is this one. Now the first thing I want to check, let's see, are we moving up? So we check if is moving up. And if that's the case, I want to copy this line. So I'm going to put this in. So we tell the object to move up. And the way I'm approaching this is I'm going to do one step at a time. So I don't need to make everything work at once in my code. I want to do it in little chunks. And I'm going to comment that. So let's really break this down. So I'm going to put run this code if the platform is moving up. And now this is a little over the top. Normally in your game, you don't need to go this detailed, but it also doesn't hurt, especially when you're starting. because you're going to look back on your code a lot and not necessarily understand what you did. So let's be really explicit. I'm going to move the platform in an upward direction. Okay, now what I'm going to do here, I'm going to put another comment. I'm going to run this code if the platform is moving down. And remember, a comment doesn't actually run at all. So all of this code doesn't even recognize this. So normally right after that bracket, we would put an else, and then we can put the code. We can put a comment right in between that. We could either put it here, or another way we can do it is we can put it right after the else. So when we put the 2 slashes to make a line of comment, it only comments out what's after the slashes. So you can still have code behind it, which is like this, and it runs fine. And we can delete these comments once we have our code working, but for right now, I'm just going to put them in here to make it clear. So I'll move the platform in a downward direction. Now for this one, I'm going to copy the code that moves the platform up. And we have it using vector3.up. So if we look, there is a vector3.down, but something else that you can also do anytime, just so you're aware of it, is we could negate this. So we could put a negative sign behind it. And this means it's going to be the reverse of vector3.up. So just like the opposite of 3 would be a negative 3, the opposite of 1 on the y would be negative 1 on the y, which means down. So either of these solutions would work. Let's just put vector3.down for this. And now to demonstrate this, let's actually set our Boolean variable. I'm going to put serialized field. So now we can see it in the inspector. Let's go back to our game and let's just see what is happening with this platform right now. Okay, so let's run our game here. So I want to select our platform. And it looks like something didn't save right with mine here, because this platform that we have set as a moving platform is now just a normal prefab. So that's something that I did wrong here. So I'm just going to delete that one that's out of here. So if that does happen to you at all, you can just select your prefab here. So we see in our prefab, we have the moving platform and we move it in, but that shouldn't have happened on yours. That's just something I did in between making videos that didn't save properly. Okay, so now you notice we have this is moving up checkbox. So if we run the game, it's not going to know when to stop, but it's moving up. But if we uncheck it, now it's moving down. So this just shows why using that serialized field to make values in the inspector here can be really powerful. Plus, if you have somebody else that you're working with that doesn't know how to program, you can make game mechanics like this to put in the game, and they can design levels for you without having to use code because they have all the settings right here. They can set how fast it is, how far to stop, if it's moving up or down, and we can take that to very much more powerful levels. Okay, let's get back to our code. So now we have it moving up and down, but now we need to do a check. So let's keep using the distance of 5. So we can use this to basically be a universal distance where we want our platform to move up 5 units and then go back down 5 units. So we have a start position. We also want to know an end position now. So I'm going to do end position. And what I'm going to do right at the start, just like we did with start position, we got it here. I'm going to do transform.position, and we can do plus vector3.up multiplied by our distance to stop. Now we covered this a bit before where we could take a vector and multiply it by something. So you just want to think of normal math. So if we have 3 numbers, we're going to multiply each number by distance to stop. So in this case, distance to stop is 5. So remember, vector3.up is a new vector3 of 0, 1, 0. So you just do normal math on this, but each one is separate. So you would take 0 times distance to stop. So 0 times 5 is 0. 1 times 5 is 5. 0 times 5 is 0. So this doesn't change our direction at all. All it does is increase how far in that direction we move. So that's why multiplying any vector 3 like this by a value won't automatically make it move in some weird direction, because the x and the z in this case are both 0, so they're not going to change. Okay, so now this gives us an end position. So now we can use vector3.distance again, but in a bit of a different way. So if you tried this on your own, you may have had a problem where you started to approach the target that you want to change at, and you overshot it a bit, because every frame we're moving a certain amount. So if we try to do something like, if we do if transform.position, and then we use the equal operator, remember it's 2 equals. So if we do transform.position equals end position, now we're not going to get an error or anything here, but these won't always be exact, because the transform.translate could go past the end position. And if we go past it, we're never going to hit it again, because we already went past, and it's just going to keep on going. So the way we want to approach this is we want to use a value for kind of like a margin of error. So we can do vector3.distance. We can take our transform.position and then our end position. And then we can say, if the distance is less than, say, let's go with 0.1. So basically what we're saying here is, are we close enough to the end position? So we might not be right on top of it, but we're going to be close enough. We're within 0.1. So if that happens, let's just go back down. So then we can say is moving up equals false. Okay, and then we can actually just copy this line of code. Let's put it under here. We need to change end position to start position. And then we want to set is moving up to be true. So let's go run this and let's see how this code runs. Okay, so we're moving up. And we got close to our position, and now we're moving back down. You can see the check actually gets unchecked each time. Okay, so now we have a simple platform that moves up and down. Now, if you accomplish this and you did it a different way, congratulations, that is awesome. That's the way we want to get into this, where you can make the assignments that I give to you work, not doing necessarily the same thing I do. At this part of the course, though, you may want to change it to match this, just because if we do something down the road, your code might not be the same. But I do encourage that for assignments of try doing things on your own. You don't have to do it exactly like I did. You don't have to use the same logic I did. As long as you accomplish the goal, that's the practice you need. But just to keep things following with the course, you may want to just copy this code just to keep it similar. And now just for the sake of it, for right now, I'm going to put a little note here. So we'll put some comments. We're just going to say, check if we are within 0.1 f distance of the end position. If so, then switch platform to move down. Okay, and then I'll put one over here. I'll say start position, and we'll say move up. So again, like I said, these comments are these are pretty redundant here. We don't need them this detailed, but it just shows how you can start using these comments to comment your code and explain what you're doing. And you usually want to do them where anything might not make sense instantly just to look at it, or to give a summary so people don't have to read through each line of code and try to figure it out. Okay, so that's it for this video. We now have a platform that moves up and down, and I'll see you in the next video.